Hello everyone, it is January 13th and today I'm doing LeetCode problem 804 unique Morse code words. Let's get started. International Morse code defines a standard encoding where each letter is mapped to a series of dots and dashes. As follows: A maps to this, B maps to this, C maps to this. For convenience, the full table for the 26 letters of the English alphabet is given below. Given an array of string words where each word can be written as a concatenation of the Morse code of each letter, return the number of different transformations among all the words we have. For example, cab can be written as C and then, oh, wait a second. So this is C right here, and this is A, and this is B. Okay? And we can call such a concatenation the transformation of a word. Return the number of different transformations among all the words we have. Okay, so then the transformation of each word, Jin is this transformation, Zen is this transformation. Okay, I see. So despite G mapping to a specific transformation in here, the concatenation of transformations of different letters together can form a complete transformation that is the same of another string's transformation. That was a mouthful. There are two different transformations. So there are two different, the amount of unique strings that come from the transformations is what we're returning. And right here, A only has one transformation. Words I consists of lowercase English letters. Okay. So the first thing I'm thinking of is because each letter maps to these specific symbols, and we're kind of given the word maps, the first thing I'm thinking of is a dictionary where we can map each letter in the English alphabet to each individual string, A, B, C, all the way to Z. And then when we iterate through words, we can create a resulting string that is the concatenation of all the transformations. So we concatenate the G, assuming that's the G, and this is the I, and this is the N. We make one complete string from that, and then we can use a set to store the string within the set. And then as we iterate through each word in the words, we can add the string that's been transformed into these symbols to that set. And then because we're returning the number of different transformations, that would just be the length of the set, because we can't have duplicates. So we would only be adding one string if we see a duplicate. We don't add each string. So that seems pretty straightforward then. So the only thing to do would be the only thing we have to do is we have to map each letter to each string. So, yep, that's straightforward. So we'll say, I'm trying not to say, so we'll just copy that over. We'll create the dictionary. And unfortunately, I have to go through every letter and do this. But that is, I'm sure there is a better way to automate that. But I'm not going to do it. Technically, I could do something like getting I almost lost my train of thought of what letter I was on. Getting the ORD value from whatever the ORD value is of lowercase a to the ORD value of lowercase z, and then iterating from those numbers. I don't remember if ORD of a is 65, so I could go from 65 to 90 something, and then do some conversions there instead of having to manually do this. But I'll just do this. A, B, C, D, E, F, G. Imagine if you forgot the alphabet during the interview. That would suck. H, I, J. I, for one, do have to, J, K. I have to say the alphabet over and over to remember what the next one is. A, B, C, D, F, G, H, I, J, K, L, M, N, O, there really should be a library to do this. Okay, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, L, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay. So for word in words, cur string equals to an empty string initially. I'll initialize the set, and then we'll iterate through the word. For letter in word, cur string plus equals to alphabet letter. So we'll get the transformation from that, and then we'll add that to the current string. Word set.add current string, and then upon the next iteration, current string will be set back to these quotes. And then at the end, we return the length of the word set. That all looks good to me. All the commas are added. Okay, let's run it. Great. Okay, everybody, that concludes this problem. There would be a simpler solution if we were given this table as an array, and then instead of having to create this dictionary ourselves, we could have used something like the ORD function of the letter we're iterating, or the letter that we're on in the word, minus the letter A, which would give you an integer, and then we could just index that integer into the array to get which string we need. But that wasn't given, so unfortunately we had to create this dictionary, unless there's some other solution I can't see yet. But I hope you enjoyed this session. I only wanted to do an easy problem because I didn't have a lot of time, but I still wanted to get those reps in. So yeah, I hope you're all doing fantastic and that your coding or whatever you're doing is going great. That's it. Thank you and take care.